In this video, I'm going to show you how to deal with intensity. We have two situations, single slit and double slit. This is double slit. So, the equation of I is I0 times cosine square phi over 2. So, if you remember, the picture would be something like this. Intensity almost equidistributed over the screen. This is the mathematical representation, which is cosine squared. And what you see probably are fringe like this: max, mean, and so forth. So what you see with your eyes, this is the distribution of intensity, and this is the mathematical distribution. Okay, this is I0 here somewhere. So we are asking this question: what fraction of the maximum intensity on the screen is the intensity measured at 2.6 meters from the center? If this is the center here, 2.6 millimeters. It could be anywhere. Let's say here, for example, or maybe here. We don't know. So the intensity will change from this I0 to 0, and in between a given percentage of I0 max value. So what's that ratio? Basically I over I0. So if I know this quantity phi over 2, then I find the ratio. So what we are going to do is express this phi over 2 in terms of the parameter experiment. This is lambda. Separate that is D, and this is L. So this is L, this is D. You can see the answer is this one, but we have to find it. And this is lambda. Alright, so let's express phi over 2 in terms of this parameter. So the starting point is this: any phase difference over the cycle to pi is the same as the path difference delta L as to lambda. This is the beginning of the story. So now from here, what is this delta L? For two slits, we evaluate to be D sine theta. I don't have to do this, but just to remind you of the procedure over lambda. Now I can solve for phi over 2. Well, I just multiply by pi, that is pi D sine theta over lambda. Okay, so we have evaluated this quantity here, phi over 2. Now we can switch to tangent for small angle to get y involved, and tangent, so let's write pi d tangent. This is small values approximation over lambda. Now the tangent, if you remember, time of saying experiment, it is the y over L. So this is basically pi d and then y over L. So this is now phi over 2 of y. I can write like this. I miss lambda here. So this is like phi of y. So it's function of y over 2. Alright? So let's evaluate this term now. This term here. Because this is what we call phi over 2 over here. Alright, pi is 314. And then I have d. What is d? 0.02 millimeters. I have to go back to meters. That is 10 negative 3. And then I have y, which is 2 millimeters. Again, I have to go back 2.6. I have to go back to meters. Divided by 1000. All divided by lambda L. Lambda is 625. 25 nano. A nano is 10 negative 9. And then I have L, and L is 1.8. Now you have to remember this quantity is in radian. You have to understand that. In science we don't use degrees. Alright, so what is this? I did the math. I find 0. You're welcome to check this number. 1, 4, 5, and I have to remind you again, this is radian. Now at this point you are welcome to put this number here, but you have to convert or change the mode of your calculator, or we can change it into degrees, which is not difficult. So in degrees, remember this is 5/2, not 5. So what I'm going to do is multiply 0.145. Since this is radian, I need radian downstairs, which is pi 314, and in degree that is 108 degrees. So radian and radian cancel out. I will have degrees. So the degrees correspond to this is 8. So this is equal to 8.3 degrees. Let's use another color. So this is 5/2 in degrees, which is 0.145 radian. Now we are ready to find the ratio. The ratio I over I0 is just cosine of that angle squared. So cosine squared. And now since my calculator is already in degree mode, so 8.3. So this quantity you are going to find so almost 0.98, which is 98%. So that means we are very close to the maximum. At that point we are either here somewhere. This is also I0, remember, this is also I0, but we are talking about the central, I think. Well, no, it doesn't say the central. So we are very close because it's 98%. It's almost the same. So we are very close, either here or here, very close to the I0. All right. So this is how we handle the intensity.